guys, in this video we're going to see about evolute. Our topic is evolute. So first of all, what is evolute? The locus of center. First, what is mean by locus? So locus is nothing but a set of points. This is very important. Just observe it clearly. A set of points. So there are many points. If we join it together, then this is called a locus. So if you take a circle is locus of point from a same distance. So this is a point, this is a point, this is a point, this is a point to this locus. So if you join it together, it forms a circle. So like that, if a curve is there, then many points will be there, and the set of points should satisfy some conditions. So that's important. So these points satisfy the equation of a circle. So the point should satisfy some conditions. The set of points should satisfy some condition is called locus. The locus of center of curvature of a given curve. So we saw center of curvature in our previous videos. So we know that what is center of curvature. So if this is a curve, then this is a point, then we extend it, it forms a circle. So the center of the circle is called center of curvature. So like that, each point has its own circle. It belongs to some circles. So each circle have its centers. So if it join together, then that's nothing but evolute. So what is inevolute? There are two concepts, evolute, inevolute. So for which we drawn is evolute. For the curve which we drawn is called inevolute. So the given curve is called inevolute, and the locus of all the center of curvature is called evolute. So it's called an evolute of a curve. The given curve is itself called an inevolute of an evolute. In fact, for evolute there are many inevolutes. So this is important. Maybe in MCQ they can ask this. In fact, for evolute there are many inevolutes. So how to find evolute? So evolute is nothing but a point. So we are going to find the points, uh, a set of points. So this is what we are going to find out. So x dash is equal to x coordinate. So x minus y1 1 plus y1 whole square by y2. So then what is y1 y2? So y1 is nothing but first differentiation of the given equation. Y2 is nothing but the second derivative. First derivative, second derivative, that's it. So similarly for the y coordinates, so x dash is equal to x minus y1 1 plus y1 the whole square by y2. Y dash is equal to y plus 1 plus y1 square by y2. So these are the most important formula which we are going to use in throughout this session. So let's come to the example one. First question, find the equation of evolute. So here we have to find the evolute, the points, and then combine it as an equation. So let us see how to do it. So find the equation of evolute of a parabola. So this is a parabola given equation. So as it is with respect to differentiating with respect to x, so you get y1, and second time you get y2, and then now take a point. So they didn't give any particular point. So you know the parametric points, general points of for it many parametric points are available. Let us take this 80 square to 80 square. If you put in this equation, it will satisfy. So take a parametric point and now substitute in the equations of a y1 y2. So you get y1 y2 in parametric forms. Now substitute in the formula which we are using to find the evolute. So x coordinate x minus y1 1 plus y1 whole square by y2. So just substitute, you get it. And now this is an important steps. So to get as an equation, so evolute is a curve, right? So for this curve there will be an equation, but we are finding the coordinates alone. So we have to make it as an equation. For that you have to bring out the arbitrary constant one side, so that from two equations, so from x and y, you get two arbitrary constant and which are same, so you can easily equate it. So they found an x coordinate and then they separated the arbitrary constant t, and similarly for y, so they done it and then they just equated it. So in place of t they just substituted t. So in some cases you have to equate t both sides, so something like that will come. So in this case just I substituted t in y dash, so you get the equation x y, and now x dash y dash. So this is the equation of the evolute that we are that they are asking, that we are intent to find out. That's it. So then second question, find the equation of evolute of ellipse. So this is ellipse. So similarly, first derivative, second derivative, finding it out. So we got it. So here the arbitrary points are a cos theta, b sin theta. So you just remember this. For ellipse, this is arbitrary points, and for a parabola, that is an arbitrary points. So like that, you just remember the arbitrary points of a particular curve, and then these are the simple calculations that you can find out by looking at the steps. You can easily uh, get to know what's happening. Just a division multiplication. That's it. So now this is y dash we got, and this is x dash we got, and now we have to combine it to form an equation. So how do we do that? This is something not we can actually see what to do. Just we have to omit this arbitrary things like that. What they did is actually first they separated the sin theta and cos theta, and we know that sin square theta plus cos square theta is equal to 1. So they done this in this way. So they took this equation, they keep cos on one side, and brought everything into in another side, and similarly for sine. And now cos square plus sin square theta is equal to this. So we came, so the arbitrary things are not present here. See, if you see, we took theta as an arbitrary thing, and theta is not present in the final equation. This is arbitrary points, but theta is not present in a final. So that's how we have to approach these kind of problems. So find the evolute of a rectangular hyperbola. This is a rectangular hyperbola. So for this arbitrary points or this, so let us take this as a point. And now as usual, differentiate with respect to x, then you get a d1, y1 and y2, and now put the points. You get a you substitute y1 y2 in the x coordinate equation, you get an x coordinate and y coordinate. But in this problem there is an important step, which is this steps. This is a very important steps, because you got this, but here you can't separate the t. So t cube, t square, t6, t to the power 6, we can't take t one side because it is not in a variable separable form. So in this case we have to add this. So in this case they added this. How do you find that we have to add or subtract, what to do? So these are all find out by many hit and trials method. So you have to just remember for this type of methods, so this is the approach to solve these problems, like that you have to remember it. And x dash plus y dash, they're just adding this, and then they are subtracting this. So they adding this, subtracting this, and raising it to the power 1 by 3. 1 by 3. So now they are subtracting the equations that we formed before. So by that we can omit the arbitrary constant t. So it is arbitrary point which we took, so it should not be present in final equation. So this is without taking arbitrary points also we can do, but many x and y's will come, many variables will come. It makes a problem which is some messy kind of things will happen. You may probably end up in a wrong answers. So that's why these arbitrary points are taken to solve it easily. So now show that so another question, show that the evolute of a cycloid. The equation given is in a parametric form, so you can also give your answer in parametric form itself. So let us see. So just they divided with respect to theta. This is very important, because then they divided to get dy by dx. So dy theta, they got it, and dy now dy by theta, they got it. So this is separate, this is separate. Now they divide this by this to get dy by dx, that is nothing but your y1. And now they again differentiate with respect to x. So here you should be careful, because first you have to differentiate with respect to theta and then d theta by dx, because the variables are different here theta, but you are differentiating theta with respect to x, so you should be careful here. So d theta by dx, we know that dx by d theta, so you have to just reciprocate and so substitute here to get the y2. So y1 y2 we got it. And now the center of curvature at x y is, so just substitute what we found y1 y2 in the x coordinate formula, you get it. So just see it, you can find out what's happening. Just pause the screen, just see what steps are doing. And now same as y coordinate, you found it. And now what they did is just leave it alone, because the given equation itself in a parametric form, so you can also give the equation in a parametric form itself, or else you can also omit the a part by combining it. It's not a big deal, it's easy only. So they gave it in a parametric form, so we gave it in as a parametric form itself. And now show that the evolute of tractrix. So what is this word tractrix means? It is nothing but the name of a shape. So this tractrix look like this, and this is missing, but this is a catenary. Catenary is somewhat look like a parabola, but not a parabola, somewhat like that. So these are the cool stuff for shapes, cool shapes, you can google it. So we have to prove the evolute of this will be a catenary. That's what we have to prove. So let t be the point on a given curve. So let's take in any point, let's t, and now we are differentiating with respect to t and then dividing it to get the y1, and now differentiating again with respect to x to get y2. So here you should be careful. And now y1 y2 got. So now putting it in an equation, putting in the formula of x dash, which is x coordinate, you get it. This is a simple calculation. Just by passing the screen and seeing the calculation, you can understand what's happening. And then similarly for y coordinate, this is a simplification. So after this, what they did is just you got it right. Just they separated it and e to the power x by a in one side, because both terms contain e to the power x, this kind of stuff. So they just separated, and then they just done a simplification to get the form, to get the desired, to what we have to prove that they got it, y is equal to a cos h x by a. So here some kind of cool stuff had happened. So what they actually did is nothing but there is a tan t by 2, log tan t by 2. They just brought the log in this side to get e by this. So from these, they substituted 1 by tan t in this equation. So from this, they substituted in this equation. So they finally got it. So this is nothing but a. So you know that e to the power x plus e to the power minus x by 2 is nothing but cos x. Cosh x. This is hyperbolic function rules. So that's what happened. They got it right. So these are all the some exercises. If you want, you can write out. Bye bye.